what is the field? We usually dealing with at least 3 fields in our life. We have magnetic fields, we have electric fields, and also the gravitational field also acts as a field. But from the electrical point of view, we anyway focused on electric and magnetic fields. So what is the field anyway? Field is a type of matter, is another type of matter. We have some physical matter which we can touch, which consists of different atoms, but at the same time we have kind of non-touchable matter, which is field matter. But anyway, the field exists and it can be measured, and the field, both electrical and magnetic, manifests itself. So there is no question that this type of invisible matter anyway exists. And let's go closer to magnetic and electric fields and understand how do they work and how they are created. If we go to the simple charge, charged particle, or even better, 2 particles. One particle is assumed to be charged positively with plus sign, another particle is charged with minus sign. And stationary charged particles, or just charges, are usually referred to electric field. Charged particles can produce stationary electric field. This is actually the part of the science which called electrostatics. And the lines of electric field, imaginary lines, are produced by positive charges. So the positive charge acts as a kind of source of electric field, and negative charge is acting as a sink for the field. So if you have only one charge, the electric field lines usually go to the infinite. They gradually reducing but never disappear. But when you have a negative charge, this electric field lines actually trending to end up at this negative charge. So we have a quite typical picture of electric field when electric field lines are traveling from plus to minus. This is very important, and this is the fundamental difference with magnetic field, that in electric field you have source and sink. By the way, electric field is measured and actually described with the vector E. This is the vector of electric field. These lines are actually not vectors, but the idea is that in every point of the space, if you draw the tangential line to this beautiful curve, you actually get the direction of electric field in exact this point. So the electric field lines basically show you the direction of the field, and the intensity of the lines actually can show you, at least give you understanding of the strength of the field. So this is what's about electric field. This is just for your basic knowledge, and in electric drives and electric machines, we actually usually dealing with magnetic field. How magnetic field is created? Magnetic field is created by not stationary but moving charges, or in simple words, electric current. If we take a conductor with some current flowing through this conductor, around this conductor different strange things actually starts to happen. For example, the arrow of a compass starts orienting in different ways and so on. Why? Because around the conductor with current in it, there is magnetic field created. So the source, not the source, but the reason of magnetic field is actually electric current. And the magnetic flux density lines represent concentric loops around the wire. And similarly to electric field, magnetic field, which is usually described with the vector B, which is the vector of magnetic induction or magnetic flux density. This vector also in every point of the space has its module and direction. The direction can be described with the right-hand rule. So when we take the wire with the current with right hand and we put our thumb finger by the direction of the current, our other fingers show how the magnetic flux density is rotating. So that means that in this part of the wire it goes here to us, and in this part it's going out from us. And as you see, the very important and fundamental difference is that there are no existing magnetic charges, and magnetic flux does not start and does not finish anywhere. It's just rotating and representing infinite circulating loops. This is very important. Even if you consider the permanent magnet or electromagnet or solenoid, so here let's assume this is a piece of magnet with north and south pole, or this is solenoid or electromagnet, which kind of generate magnetic field. So magnetic field goes out from the north pole and going into the south pole, and the same in the solenoid. Actually, magnetic flux is not finishing here. Magnetic flux is just going through the magnet inside. So the loops are anyway closed, and the magnets or solenoids acting just as a pump for this flux. That's it.